Okay, guys, so lesson 2.7, unit 2, lesson 7. Okay, we're going to do more properties of integer exponents, okay? And so our essential question is, what do the zero exponent and negative exponent properties mean? And we're going to get to that, okay? I'm going to do this a little bit differently. So we're going to go over here first, and we're going to look at the problems they talked about in example 1. Now, the ones they talked about in example 1, guys, actually deal with the zero property exponent, okay, the zero exponent property. All it is, and you're going to see this with all of these, anything to the zero power is 1. Okay, and they explain that in a lot more detail in the examples, but you got to remember that. Okay, so in other words, if I have -7 to the zero power, that's 1. If I have 43 to the zero power, that's 1. If I have 1 to the zero power, that equals 1. If I have 0 and 5/10 to the zero power, that equals 1. Okay? But then the question they ask why, and some of the students don't understand this, is why then would 2 multiplied by 7 to the zero power be 2? Well, it's simply because 7 to the zero power is 1. We multiply 2 by 1, we get 2. Okay, guys? So just remember, anything to the zero power is 1. The reason is the zero power means that we're dividing that number by itself. Okay, we're dividing that number by itself. So in other words, -7 divided by -7 is going to be 1. 43 divided by 43 is going to be 1. Okay, so that means we're dividing it by itself. Okay? Let's look at example 2. Okay, so example 2 right here. Now, so we're looking at quotient of powers property. That means dividing numbers with exponents, okay? Now, I went over this a little bit in yesterday's lesson, but I want you guys to see it again. So here's what we're looking at. What they're saying is that this is 2 to the third power. That means it's 2 multiplied by 2 multiplied by 2 over 2 to the fifth power. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. This means that these 2's cancel each other out, and all I have left is 1's then, so this is 1, and then 2 multiplied by 2. So this is actually going to equal 1 over 2 to the second power. Okay, if you remember yesterday, I said we subtract the numbers, and then wherever the larger exponent is, that's where it will go. So it would be 5 minus 3, which is 2, but because the 5 exponent's on the bottom, that's why that 2 to the second power is on the bottom. Now remember, this only works if the bases are the same. The bases here are 2, and that is the only way it works. Okay, guys? All right. The negative exponents property means that we can have negative exponents. Now remember this, guys. Just because we have a negative exponent does not mean it makes a negative number. Negative exponent simply means that it's going to be less than 1. Okay? So anytime it's a negative exponent, it's less than 1. If I have this and I want to turn it into a positive exponent, all we do is look at it like this. See how I have 8 to the negative 2 power? If I make this into a fraction, I'd put it over 1. In order to make this -2 positive, what we do is we do the reciprocal. In other words, I would say 1 over 8 to the second power. Because it goes below the line, we do the reciprocal of it, then it becomes positive. The same thing goes here. And I put this over 1, we do the reciprocal of it, it's 1 over 2. Ooh, look at me mess that up. Over 1, right? Not 2. 2 to the fourth power. Because it went to the other side of the line, then it became positive. And finally, the last one, put it over 1. This is going to equal 1 over 3 to the fifth power. So anytime you have any of these, and this is very important to remember, if you have a negative exponent, do the reciprocal of it to make the exponent positive. Okay, guys? Okay? Any of the stuff you don't understand, you need to ask me questions on when we come into class. Okay? Okay, so now we'll go to example 3. Okay? Example 3 here is talking about when it's on the bottom. Okay, so this is the same as what we just went through. I've got a negative exponent. I want to get rid of that. So what I'm going to do is I'm actually going to do the reciprocal. So this becomes 5 to the third power over 1, which actually just equals 5 to the third power. That's it. So B, same thing. I'm going to go through. This is going to be 2 to the 6th power over 1. I just put it on the other side so that the exponent would become positive. And then this becomes 2 to the 6th power because it's just over 1. Okay? The one that confuses people, and I added this in myself, you won't actually see this in the example, is this one right here, negative 15 to the 0 power. Now remember, anything to the 0 power is 1. So this means that this equals a negative and then a 1 inside, right? So that's like taking a negative 1 multiplied by 1. So this actually equals a negative 1 still, even though the inside and the ones I showed you over here had a negative 7 to the 0 power. That became a 1. Okay, this one, because the negative is outside the parentheses, we have to multiply it by the number in the parentheses after we solve within the parentheses. Remember, we're talking about PEMDAS here, right? Okay, so in other words, we solve the parentheses first, right? We solve the parentheses first, whatever's inside of it. 15 to the 0 power is 1. Then we look at the exponents, which the exponents we don't have after that point. But then we do multiplication and division. And this is virtually what this is. It's like a negative 1 multiplied by 1, which equals negative 1. Okay, guys? Hopefully I'm not talking too quick. Okay, now, I'm going to need your patience here, because I'm going to go through a problem that is in the quiz. And I didn't have enough room to put all this up here. So what I did was I put as much up here as I could, knowing I was going to write this out. Plus, I think this is important for you guys to see. So we have a few different ones here, okay? This is what they're saying. Is 5, oh, and I should tell you, this is quiz number 5. Okay? If I have 5 multiplied by 1 over 5 to the third power, does that equal 5 multiplied by 5 to the third power? Now, it's going to ask you more than that, but I'm going to solve this for you so you can see what we're talking about, and hopefully this will give you a greater understanding of all this information. Okay? So what we need to understand is this. This right here, this 5 is going to stay like this, okay? But this is actually 1 over 5 multiplied by 5 multiplied by 5. 5 to the third power, right? And this equals 5 multiplied by 5 multiplied by 5 multiplied by 5. Now, when I have a fraction over here, what I want to do is I want to turn these both into fractions. In other words, it becomes 5 over 1 multiplied by 1 multiplied by 5 multiplied by 5 multiplied by 5. If we notice, this would cross cancel this. Remember the cross canceling? We have the multiplication sign in between so we can cross cancel. Over here, I don't have any fractions, so I'm going to solve what's in the parentheses first. So I still have this 5 out here. This is 5 times 5, which is 25, times 5, which is 125. So we're still solving here, right? So on this side of the equation, we're down to this. This became 1, this became 1. 5 times 5 is 25, so this becomes 1 over 25. On the other side of the equation, this becomes 5 times 125, which is 625. So in other words, these are not equal. And that's what they're looking to ask you, are these two terms equal? Well, they are not equal, because one is 125th, this becomes 125th, and this one becomes 625. Okay? So that's what I wanted to make sure and show you, is that that does not work. Okay, guys. All right. So hopefully that helps you enough with 2.7. Don't forget, if you have any questions, come to me, ask me questions at class, go through all the information. I know this is going pretty quick, but you guys need to keep up, all right? So that we can finish the curriculum and you guys are ready for the 8th grade. Okay, so don't forget the rules of how to finish a whole lesson. Go over that again. Remember that video's on the front of your homepage. All right. We'll talk to you guys later.